In one of the spiral galaxy Milky Way's arms, about 4.5 billion years ago, a young star formed from a dense cloud of cosmic dust and gases. Around it, about 10% of the total gas and dust remained. This was the raw material for the formation of other objects. Gradually, dust particles clumped together upon collision, forming large chunks, while lighter elements evaporated under harsh solar radiation. Due to impacts from celestial bodies and radioactive decay, a protoplanet emerged, a large embryo in the protoplanetary disk. Its primary material became so hot that it melted, causing lighter compounds to remain on the surface and heavier elements and compounds to sink deep within. The interior separated into a core and mantle, and the protoplanet became a planet. This is how Earth appeared. The Panspermia hypothesis. Life from space? In the first few million years of its existence, Earth experienced numerous collisions, leaving deep scars on its surface. About 4 billion years ago, another meteorite crashed into Earth, which had previously collided with a comet, scattering many fragments onto the planet that contained biological organisms. Microscopic forms in a state of anabiosis survived a long journey in space. Upon colliding with a planet that had suitable conditions for life, these microscopic travelers became active again. The first living organisms appeared. Life appeared on Earth. This is what the Panspermia hypothesis asserts. According to this hypothesis, life exists in outer space and is distributed between planets, stars, and even galaxies via asteroids, comets, and other objects. The essence of panspermia is that life itself is simply one of the fundamental properties of matter, and the question of the origin of life is on the same level as, for example, the question of the origin of gravity. Extremophiles and evidence for panspermia. Earth is home not only to humans but also to a multitude of various organisms, among which are extremophiles. As their name suggests, they can thrive in the most extreme conditions, near hydrothermal vents at the bottom of the ocean or in acidic environments. One species withstood gravity 400,000 times greater than Earth's and didn't even flinch. Some types of extremophiles survive at extremely low temperatures and withstand high doses of radiation. In short, they survive everywhere for extremely long periods. It would be reasonable to assume that they could survive an impact that would destroy their home planet, undertake a space journey, and colonize another planet. Life on Earth could very well have originated this way. For a long time, many serious studies have been dedicated to finding evidence for panspermia. Discoveries concerning the impact of radiation on biological organisms have significantly weakened this hypothesis. The discovery of cosmic rays also contributed to this. Nevertheless, the main argument of panspermia proponents is a find made in Greenland. Microscopic organisms, approximately 3.8 billion years old, were found here. In addition, the Apollo space mission found living microorganisms of terrestrial origin on the Moon's surface. To prove or disprove the theory of transport, in 2012, several containers with fungal spores and thermophilic microorganisms were placed on the Bayan research apparatus, which was to be sent into open space. The plan was for the organism samples to be in a vacuum to maximize the replication of conditions that occur when a celestial body passes through dense atmospheric layers. Studies of some meteorites have shown that their surfaces contain remnants of simple filamentous organisms resembling lower fungi. In addition, fossilized bacteria have also been found. However, a simple check established that instead of organic compounds, the surfaces of the celestial bodies contained complex carbon compounds, which, although organic, are not related to life. In 2014, German and Swiss scientists found that DNA is resistant to the extreme conditions that occur during spaceflight, as well as during re-entry into Earth's atmosphere. This became another indirect proof of panspermia. New insights and counterarguments. However, recent studies of the Moon do not speak in favor of panspermia at all. According to one of the most popular models of the Moon's formation, it was caused by the collision of Theia, a protoplanet, with Earth over 4.5 billion years ago. The collision ejected matter from Theia and proto-Earth into space, and the Moon formed from this matter, which explains its surprising geological and chemical similarity to our planet. If this is indeed what happened, what was the fate of our satellite after this event? Initially, the Moon looked nothing like it does today. It was more like a glowing ball of lava, possessing an exotic superdense atmosphere of silicon and metal vapors. At the same time, it was 10 times closer to Earth's surface than it is today. Scientists concluded that one of the Moon's features may indicate that Earth lacked oceans of liquid water for the first 400 to 500 million years of its existence. Such conclusions, in turn, place serious limitations on the timing of life's origin on Earth. It is now generally believed that in the few million years following its formation, the Moon rapidly moved away from Earth due to tidal forces, eventually reaching its current orbit. Subsequently, this process slowed down sharply, and now it is moving away from our planet at a rate of approximately 2 to 4 centimeters per year. However, scientists have revealed one unusual detail of this process by focusing on the Moon's most mysterious feature, its unusual bulge located at the equator. This structure was discovered 2 centuries ago, when it was noticed that the Moon is flattened about 17 to 20 times more than it should be, given its rotational speed. Researchers believe that the existence of this structure indicates that in the distant past, the Moon rotated significantly faster than it does today. American planetary scientists tried to understand how quickly the Moon braked by studying the structure of this bulge and trying to reproduce its appearance using a computer model. These observations revealed that commonly accepted theories about the Moon's rapid braking in its early years are incorrect. The Earth's satellite's rotational speed remained high for at least the first 400 million years. Otherwise, the Moon would have always remained a liquid planet or had a completely different shape and size than today. This is only possible if Earth was not covered by an ocean of water comparable in size to the planet's current hydrosphere at that time. This means that there was no liquid water on the young Earth. It was either absent in principle or it was brought later, after the Moon's bulge formed. Or it was present in solid form, i.e., as ice. Such conclusions place serious limitations on the time of life's appearance on Earth and make scientists doubt that the first living organisms could have originated on our planet 4 billion years ago. This means that the finding from Greenland needs to be re-verified. New avenues for panspermia research. Throughout its existence, panspermia, like any other concept of the origin of life on Earth, has been revised and supplemented several times. For example, Professor Arjun Barrera from the University of Edinburgh proposes another possible method for transporting viable molecules. In his research, the scientist considered the possibility that cosmic dust could facilitate the escape of particles from Earth's atmosphere. These include molecules that indicate the existence of life on Earth, so-called biomarkers, but also microbial life and molecules necessary for life. These molecules consist mainly of those present in the thermosphere. At such a high altitude, these are usually simple particles, molecular nitrogen and oxygen. But it is known that even at these high altitudes, there are large particles capable of harboring bacteria or organic molecules. Professor Barrera's research shows that major catastrophes like asteroid collisions may not be the only mechanism responsible for life being carried between planets. The assumption that cosmic dust impacts can spread organisms over vast distances between planets creates some exciting prospects for how life and planetary atmospheres originated. Streams of fast cosmic dust are found in all planetary systems and may be a common factor in the spread of life. In addition to a new approach to panspermia, this study is also of great importance when it comes to how life evolved on Earth. If biological molecules and bacteria were continuously escaping from Earth's atmosphere throughout its existence, it could mean that they might still exist in the solar system, possibly inside comets and asteroids. These biological samples, if they could be obtained and studied, would refine the timeline of microbial life's evolution on Earth. It's also possible that terrestrial bacteria survive today on other planets, perhaps on Mars or other bodies, where they are trapped in permafrost or ice. These colonies would essentially be time capsules containing preserved life that could be billions of years old. It turns out that cosmic dust, periodically coming into contact with Earth's atmosphere, could have brought life to our world billions of years ago. If this is true, this same mechanism may be responsible for the distribution of life throughout the universe. Directed panspermia and the alien signal. But, as with any other hypothesis, panspermia has a drawback. It absolutely does not explain the emergence of intelligent life on Earth. Although, a truly amazing find was made in 2015. A group of scientists discovered a tiny but very interesting object. They sent a balloon to an altitude of 27 kilometers to collect dust samples and other particles. And they found something interesting. A tiny metallic sphere, as thin as a human hair, collided with the surface of the sample collector attached to the balloon, leaving a crater similar to those left by asteroids falling to Earth, but in miniature. This suggests that the sphere was moving at high speed. This small impact crater confirms that the sphere arrived on Earth from space. An object from Earth cannot move at such speed when falling back to Earth. X-ray analysis of the sphere showed that it was made of titanium with traces of vanadium. Titanium is one of the strongest metals known to man, and it has a fairly high melting point. This led scientists to conclude that the sphere could well have been manufactured and be of extraterrestrial origin. The sphere's surface was covered with a fungus-like matte layer, and biological fluid seeped from the center. The organic components surprised the scientists. However, they believe that the sphere was contaminated by particles of terrestrial origin. Further analyses of the samples will show. If NASA discovers similar particles in the stratosphere and confirms their extraterrestrial origin, it will be a point in favor of panspermia. Humanity itself can create new life with a single capsule sent to the right place at the right time. Even if it's currently science fiction, there's nothing complicated about the idea of sending a caravan of microbes under a solar sail. Perhaps we have already unconsciously sent extremophiles to Mars. Point 1. Perhaps they have already established their colonies. We can only guess. The hypothesis of directed panspermia raises several legitimate questions. Was life consciously sown on Earth? Was it sent by a sufficiently advanced civilization more than 3.5 billion years ago, when our planet was young and sterile? How too can we find the answer to this question? Since the early 1980s, some have suggested that 3 deliberate seeding of life could be proven if the genetic code of the first microorganisms on Earth contained distinctive signature messages, for like a calling card from the first engineers. In 2013, a group of physicists found indirect evidence for this. According to 2 scientists from Kazakhstan, this is the case. They believe that our genetic code contains an extraterrestrial signal, encoded billions of years ago by technologically advanced aliens. It's no secret that DNA is a powerful way to store information. Scientists looked for a code embedded in human DNA that Darwinian evolution could not explain, calling it a biological search for extraterrestrial life. Remarkably, the human genome partly supports their theory. The Kazakh scientists concluded that the DNA they identified could be up to 10 billion years old. And yet, the age of Earth itself does not exceed 4.5 billion years. Today, panspermia is one of the most widely accepted models for the appearance of life on Earth. But like any other theory or hypothesis, panspermia has its supporters and opponents. This is quite natural.